have this thing that the two gradients have to be scalar multiples of each other. All right, so how do you actually solve one of these? What's going on here is the f of xy is your surface, so that plastic thing was the f of xy, and the hiking trail is the curve, this constraint. This is a two-dimensional curve that you can plot it. In fact, you got here. So I know that you know how to plot a circle. That's a circle of radius 5. So that's on the xy plane. That's what you would draw. That's the hiking trail. It's the blue hiking trail, and the other part is the red surface. And so you're trying to find that max and min points along the hiking trail.
Are we talking about absolute maximum or local maximum?
You're looking for the absolute maximum. So yesterday you had 5 points. They were all suspects. One of them was the absolute min, and one of them was the absolute max, right? So how do you do it? You put all your suspects in one room, and you identify the thief, right? So we're going to do the same thing. So step 1 is to rewrite the constraint as g of xy equals 0, like pull everything over to the left side. So I take that constraint equation and set it equal to 0. I said g of xy, but this is your g of xy, right? This garbage right here is your garbage is g of xy, the constraint. Step 2, when you're taking notes and you want me to slow down, just say slow down, because I realize I'm going really fast. Your object, like it's nice to know what you're doing, why you're doing it. You're going to stick it into that equation, the green equation at the top. That's what you're doing. So you need the ingredients for the equation. Gradient of f is you're throwing your paper around? Just so you know how things are graded, these are bookkeeping problems in the first place. So it's in your benefit to keep them all nice and neat as you're going through. But how things are graded, which is really hard for me as a teacher because I can see if you understand something and you transcribe something wrong, but they'll look 2 points for this, 2 points for this. So if you're writing fx is 3 and fy is -4 and your fy is -4 is down here and your fx is up here and that they can't find it, it's hard to see that. And when I say they, we group grade, I'm not likely to be grading your class. So, and like make it easy for someone to say, yes, this person has 100%. And we are all going to get 100% on this problem because it's a cookbook. You just go through. Okay. Step 3 is to set up your Lagrange equation. So this is, you start with this. And then you're going to pull out the components. Can you go through solving for gradient f and gradient g again? It's just the partial derivative with respect to x is the first component, partial derivative with respect to y is the second. So let me put little notation here. Gradient f is the vector of partial derivative. Correct, and that's why that's my caution to you. Like, if you just are blasting through this problem, and your fx is somewhere here, and you wrote your fy as a little scribble down here, and the person can't see this, this is what's the 2 points. They're going to be looking for that. So put it into that vector form. Make sense? And then vector Same thing. It's gx comma gy. That's the gradient, how you define the gradient. Okay, any other questions? He put his fx at the little corner. He did that? Yeah, I thought so. I used to have a student, Brandon Petruk, who put one letter on each page, and I still couldn't read that one letter on that one page. So the equations come from setting the components equal. So the components are 3 equals lambda times 2x is the first one, and minus 4 equals lambda times 2y. That's the second one. Yes. I come from a really large family. There's 6 kids. Thomas, Catholic, big family. My sisters are just utterly amazed when they saw my math because I'm a mess everywhere else. And so my sister's reading through my stuff and going, "You're very, very neat here." Yes, here, one spot, nowhere else. Come down to my office. There's a lot of junk food down there, and then you can see my office. It's a fun place, but it's not neat. But this is neat. I'm labeling things because I'm intending to do things with it. I want my reader, which is you right now, to know it. And if I was sitting in your seat, I want my grader to know it. So once you set those equations in, step 4 is to solve for both x and y in terms of lambda. So this is like high school commutative algebra. Not even high school. You guys probably learn it in 6th grade now. It gets younger and younger. 6th grade commutative algebra. And I labeled where I got it from, just so you're tracking. It's coming from equation 1, just solving for x. Coming from equation 2, I just solve for y.
For x, shouldn't it be 3 over 2 lambda? Not 3x?
Oh, sorry, right, you're right. Even with all that neatness, I still made a mistake. Oh, that was right too. Okay. Step 5. Now you use the constraint to solve for lambda. That's your hiking trail in blue. That was the formula. You take the x and the y and plop them in here. So you get, instead of x, you're going to get 3/2 over lambda squared plus minus 2 over lambda squared is equal to 25. Pop them in there. Can I just do Rocky theme music? Well, no, I'll solve it. I was going to say Rocky theme music, and the answer is, let's do it all the way through. Common denominators. The happiest day of my career was when I saw that Mathematica can do this stuff for me. I thought, I can go get a PhD now. Somebody else is going to do the algebra for me. All right, so when I combine that, I get 25 over 4 lambda squared is equal to 25. Deliciously cooked problem. So that tells me if I cancel the 25 or cross multiply, however you want to do it, I get 1 is equal to 4 lambda squared. Bless you. And then I can take the 1/4 to the other side. So lambda is equal to plus or minus 1/2. My lambda looks like an X. I'm trying to get better about writing on this. With me so far, it's just crunching through. That's all you're doing. How long can you hold on to these computations? I had a quarter, which is 3 months, where all we did was one proof. Every day when we came to class, he would pick up where he left off the previous day. How smart people can be, right? Humans are capable of so much smartness. Like, you think of the Lagrange stuff. That's why I asked you guys yesterday, how did he come up with this? It's really remarkable. Got it? Or you need it? Yeah, it's okay. It's okay to slow me down. Question?
We plug in lambda into x and y, those are fully.
We're not there yet. You have to solve for that lambda, which I did, right? And next we're going to go back and get the x and the y. You plug them back into the original function. Those are your list of suspects. And in this case, this was an easy problem. One of them is going to be max and one is going to be min. But you're going to get some of them, which if you remember the contour plot, you had 5 points. One of them was the absolute max and one of them was the absolute min. The rest were local, right? Do you remember that? So I just gave you an easy problem to start with. So there's only 2 points. One happens to be the max and one happens to be the min along this trail. But you could get like 5. And then you make the list of f of x, y, and then you pick which one's the max and which one's the min off that list, right? This method only tells you the suspects. Make sense? Okay, so step 6. That's lambdas plural. Plug the lambdas into x and y. So I get x is equal to minus 3 over 2 times 1/2. This is lambda equals minus 1/2. And that's equal to minus 3 over 2. No, that's 3 over 1, which is minus 3. And y is equal to minus 2 over minus 1/2, which is equal to 4. So the point I get here is minus 3, 4. Because the 2 was negative. The half is negative. The lambda is minus 1/2. I just try to keep my negatives on top. I just moved my negative power on top, my negative sign on top. It was one of my lambdas. I got 2 lambdas. So this is my work for this lambda. Now I have another one. Lambda equals 1/2. For lambda equals 1/2, I get x is 3 over 2 times lambda, which I get 3 here. And y would be minus 2 over lambda, which is negative 4. So the other point was 3, negative 4. So I get 2 points for these 2 lambdas. How many would you have got if you had a function from the stuff that you did it by hand on the contour plot stuff that you did yesterday? How many points would you have? What?
1, 2,
you did. Do you remember how many you had yesterday? You found it by hand. It's like looking at your curve where the contour plot kisses the contour. It's 5. So you'd have 5 of these. It's labor intensive. Last step. I promise.
And how would you have 5 of them though? Like where did like 5 different X, Y values or small?
You'd have a bunch of lambdas, maybe more than one lambda. You'd have to have 4. It will fall out of your algebra. It'd be a very cruel thing to hand to somebody to do. It's a lot of labor-intensive algebra. You know, you can imagine it when you're doing the stuff. Like my thing was really easy. It turned out to be lambda squared equals 1/4. But you could have like something that factored out with 5 roots. So you had 5 different lambdas, and each one gave you a different xy. It can happen. They're not going to do that. There's no need to do that, right? Like if you really want to get those lambdas, you can crank it through somewhere. Go ahead.
What did you find when you plugged the lambdas into the?
These are the locations, the suspects for the maxes and mins.
So they're not, like we don't know them.
We don't know yet. Last step. I told you we're getting there. I didn't put them in the same order. I don't know why. I forgot what my f of xy was, but you plug them back in there and you get the f of xy values. I forgot what this was. Do you remember? It was something easy.
3x minus 4.
Yeah, it was something easy. That's what I'm using there to get these values. The largest, so a scenario, you could have 5 of them. The largest f value is your maximum. The smallest f value is your minimum. And we only have 2 here because of hot cooked off stuff that I'm giving you. So max here. So step 8 is make conclusion. Maximum height is 25. Min is at 3 minus 4, which is minus 25. And I can see that from the table. I just made it easier so that you don't have a whole bunch of them. I have like 3 meetings on top of our class. I'm going to go insane. I see your look. You're already there, Dr. T. You're already there. Oh, is this clear? Now you try one. Go ahead. What's the question you don't understand?
I'm just looking at that. -3 and 4.
Like if I put -3 in here, so I get it backwards, -3. This is like, I got this sign switch. Oh, minus sign errors. Correct? Good thing it was the easy problem. We have 5 of them. All right, you guys try this one.